Welcome back, everybody, to the security stream. We're really sorry about the delay, but we're all here now. So, hope you enjoyed lunch or the previous session that you're in. So this is the security stream for the GSE Virtual Conference 2023 that you're participating in. My name's Jamie Pease. I'm the chair of the Security Working Group. And our next presenter is Al Surratt from Maintegrity, and Al's by no means a stranger to GSE. You were at our GSE conference, weren't you, Al, back in November last year, and various other GSE events that we've held. So Al's come to talk to us about a topic that I think gives some of us sleepless nights, sometimes in our personal lives. But also more importantly, should do in the business world, and that topic is about ransomware. So without further ado, Al, I'm going to hand over to you. Welcome back.
Jamie, thank you very much indeed, and thank you for everybody else. I do apologize that being a bit late. I had a few little technical challenges on the way in this morning, but hopefully I can make up with that with better content and some new ideas that are a little different than are in the marketplace today, and how we can deal with some issues that really do, as Jamie says, keep me up at night. This morning we're going to talk a little bit about ransomware attacks. I'll go through a typical ransomware attack. I'm going to talk about technology with respect to integrity monitoring. And that's a general technology that's available on many platforms, but really hasn't been adopted as much in the mainframe area. And we're going to talk about that in what it can really do for you in terms of both prevention and for recovery in case bad things happen to you. So with no more than that, I'm going to get right down to the content. I'll be very happy to talk to everybody on the session this morning, and hopefully we can get some good questions in from the field when we're finished the formal part of the session. So just a little bit about Maintegrity. Who are we? We are veteran enterprisers. I have been in the enterprise area for more than 40 years, and most of the rest of the team have been 30 plus. So we really are dedicated to the platform, to mainframes, to ZOS in particular, and providing solutions in that area. And really our mission is to make the mainframe more viable than it has been in decades. And thank goodness, I think many of us are working the same way. So thank you for all your efforts to keep the mainframe viable, to keep our corporations and organizations safe, and for moving ahead. We really focus on file integrity monitoring, as well as connectivity for the mainframe into a variety of environments, but we see the mainframe as the center of an ecosystem that includes many different platforms, and we interconnect with those platforms such as Linux, Windows, cloud environments. So we focus on providing superior customer solutions. And with that, I'm going to turn things back to where we said we were going to go, which was integrity monitoring. Integrity monitoring is a general technology, and the technology itself, the underlying technology, has been around for probably 40 or 50 years. Certainly, I ran into hashing and checksum processing very early in my career, and that's now quite a long time ago. So integrity monitoring has come a long ways from that point, and really it's used on almost every platform other than the mainframe to prevent successful attacks. We utilize the mainframe for that process and run integrity monitoring to actually take full advantage of its exceptional security environment. And really, integrity monitoring is an equal partner to things like enterprise security, where you're securing access to the mainframe and that sort of thing. We really look hard at monitoring both the system and the application data sets with integrity monitoring. And we're looking for unwanted and malicious changes. That means we need to have an whitelist that is up to date at all times, so we can find those malicious changes and unwanted changes. The alerts that we're looking for is to protect static information, things that are programmatic in nature, so software or load libraries, JCL that runs your production environment, farm lives, and also backups in a little different context. Those are the kinds of things that should not change. Constantly changing databases are not really good targets for integrity monitoring, because what we're going to do is we're going to assign a hashing code, and we're going to go back and we're going to look at that hashing code and make sure that nothing has changed unless it was changed by production deploy services. So in short, what can integrity monitoring do for you? Okay, what we set up, as an industry, integrity monitoring needs to be set up in such a way that it can combat external ransomware and malware attacks. In addition to that, look for those things that do not belong on your system. Look for those changes that are malicious in nature. So malware is a key element. You've heard of phishing campaigns and all of the rest of the attack vectors. But really what we're trying to, what an attacker is trying to do in that area is deliver a payload that can undo all the security in your environment. We need to find a way also to neutralize these malicious insiders. Insiders are people that are probably good employees, but for some reason go rogue. They come offside with the company for some reason. We need to look for the kinds of actions that betray the way that they operate. Now, that tends to be less in the integrity monitoring space than it does in the continuous monitoring space, and I'll differentiate between those two in a couple of minutes. Then you need a way to respond. So first of all, we need to defend and protect as much as we can so you don't get attacked, but you don't have a successful attack at any rate. But the next thing that we have to do is, if they manage to get inside your walls, we have to detect them. But further than that, if something bad happens, we have to be able to respond. We have to respond quickly. And that means we have to do situational analysis, and that leads us to forensics. The next step in a process of recovery now is to do a surgical recovery for compromised software and parameters. That's your infrastructure. And there's no point in recovering data until you've patched a hole that you've identified with integrity monitoring. Then, of course, we'll need to recover that data. And often enough these days, that comes from immutable backups. But data recovery of information stored in immutable backups can be a bit of a challenge. So, integrity monitoring, if it's set up properly with the right ancillary capabilities, such as restore capability, can actually look at those immutable backups and make that data much more accessible. If we do all those things correctly, we will have complied with the intent and the actual nature of many of the resiliency requirements that banks and financial institutions are placed under, but also more of the classic security standards such as PCI DSS, NIST, or GDPR. Again, if we're successful in automating a lot of that with integrity monitoring, we'll save on admin and compliance effort. Most of the time, we look at firewalls or enterprise security packages and access control as the key to our kingdom, and that doesn't change. We still need to let the good guys in to do their work and keep the bad guys out. But the bad guys get a little smarter as time goes on, and they've learned to steal credentials. And these days, they don't even have to do that. Lots of nefarious characters run phishing campaigns and then make the credentials available on the dark web for sale. But as I said, a more dangerous problem is if trusted employees go rogue, via gambling or some type of addiction, or to become disgruntled with the company. They already have all of the access they need. They have the fobs, they have the MFA, they have passwords and user IDs. That means they've got access, but furthermore, they also know what to attack. So we need to expand on base integrity monitoring to be able to look at the actions that they need to undertake in order to attack you from the inside. And those actions often look legitimate, so they're really hard to find in millions of legitimate SMF records. Even if you have an SIEM that contains all of the information from SMF on the mainframe, it's still a great big job to go in and find out which ones are real and which ones are a false positive, but look like they could be an issue or look suspicious. So integrity monitoring helps make that a black or white situation without false positives. Really, at the end of the day, no matter how good your perimeter defenses are, if criminals are motivated enough, they'll break in. Their first step is always to gain access. And they do that in a number of ways. And I'm sure everybody else in the security stream has been talking to you all morning about how long that will take and the various routes into your system. So I won't spend any more time on that. But what do they do when they get inside your system? Then they actually will start implanting bad things. So one of the things that almost every ransomware attack has these days is a component whereby when I break in, I want to make sure that since breaking in is a lot of work or costly endeavor, I want to make sure that no matter how good the defenses are, I can get back in when I want to, and I can make my ransomware request successful. So once I've gotten access, the first thing I'm going to do is I'm going to insert other backdoors. And then I'm going to obscure the one where I broke in the first place. That way, I'm trying to shield myself from the scrutiny of monitoring tools. Same thing is true if I look at time bombs or things that go off sometime later on by way of some sort of date check. So just like a backdoor, it gives me another way to go back in and compromise a now recently restored environment. So if I'm lucky enough to get all my data back, the time bomb will simply have a date set in it so that it would take action, harmful action, the kinds of actions that once I've gotten in as a hacker, once I've gotten in, I'm going to threaten you, I'm going to hurt something sensitive. Well, that time bomb at a specific point in time, unless it gets a key, will do the same sort of thing. So those are very malicious activities that get welded in to your software layer. In this case, as they go further, they might even try and compromise your backups. Backups are critical in restoring. If you have immutable backups, then that's something that they don't have access to. That'll be there in case you need to recover. But those recoveries tend to be fairly complicated, and you'll need help stepping through that. So if they can get to the backups that you need to, which are often enough your conventional backups that you need to recover from, or at least recover your software from, you still have your primary recovery asset having been compromised. So that's a major problem. Then they'll actually mount the real attack and try to encrypt your database and send you a ransomware request. Integrity monitoring works to combat that. And in fact, it works in this particular way. So we detect and recover from gaps that malware exploits. So how do we do that? First of all, we're going to use the hashing capabilities that are on every mainframe today to create a hash code for each module that we're protecting. So in many cases, we look at integrity monitoring, accessing your entire system environment. So not only ZOS, but also CICS and the other database tools along the way. But in addition to that, your applications, things that shouldn't change, your parameter sets, things where I can open a door or change a parameter such that I can get access where I shouldn't have had any kind of access before. Integrity monitoring can scan all of that environment. And we scan that by creating a baseline for each member, for each file on your system. That's a new way of looking after your trusted system environment. And we continue to come back and check that. So we create that baseline. The baseline is composed of a hash code for each module. In the case of software, we often see those being thousands of modules. And in a modern integrity monitoring product, they can be identified and managed and monitored in seconds. In addition to that, a good integrity monitoring product needs to learn from the deploy processes in your production system of the changes that are going through. If I got my baseline created, and everybody can through automated processes now, I then need to simply attach a step to your deploy process that allows the integrity monitoring tool to pick up those changes and update the baseline. That means at any point in time, I have an up-to-date baseline or whitelist, and that means that anything that's not on the whitelist is a problem area and subject to investigation. Now, there's only really two sources for that. Either a legitimate change that for some reason bypassed your deployment process. That in itself a question as to how you will need to look at that to ensure that doesn't happen again. But it could be an emergency change that happened overnight. Otherwise, it is truly a malicious action. And that means that in either of those two cases, action needs to take place. So it's not a false positive. It's something that really has to be dealt with. Subsequent scans then simply go and recreate all of the baseline information, compare it to information, the hash codes that are then stored in that encrypted data set. So if we find a problem, it is either bypassed your deploy process because it's malicious, or bypassed because it's an emergency change that went awry and needs to be updated. Following on from that, we know we have a problem. We need a way to investigate. The best way these days is to investigate in the browser environment. There's so many different aspects to look at. Really, a browser is a much more rich method. A standard old GUI, a standard old 3270 interface, it's a lot of clicks in order to drill down and find out what's going on. But with a browser or GUI interface, you can paint all of that information, probably from multiple sources, probably including SMF from from various repositories of security information in the site. Good integrity monitoring will provide a forensic capability as well as basic integrity monitoring. And then integrity monitoring knows what has been changed. So it's possible to do a selective restore for the software that needs to be brought back with no regression. Once we've done all that, we can really start working with the backup tools in order to get the restore of the data done. But if I don't start from your trusted system software environment, I won't be able to tell which components need to be restored. What's it look like on a timeline? Typically, an attack, when are you notified of a successful attack? Probably when DB2 or IMS fails, because a standard attack process is to encrypt the database. The next thing I have to do is break into my recovery process. However, there are things that come along before the attack that are necessary in order to mount the attack. And those are malicious changes that the perpetrators might put on your system, which is what integrity monitoring focuses on. And even earlier than that, a reconnaissance phase, where a certain amount of looking around takes place. I'm searching for what the sore point or the sensitive point in the system would be, and I'm taking characteristic actions that look a little different than what normal operation looks like. So we can key on key elements in both reconnaissance and in the insertion of malicious code to actually prevent the attack from occurring. So in an integrity monitoring environment, we focused, and I told you about how we detect actual changes to your system. In addition to that, there's another process which is linked very tightly, which is continuous monitoring. And that's the kind of thing that looks at your system between scans and looks for suspicious actions and reports them at an earlier stage. Both of these two steps are necessary to prevent the attack in the first place. If you get into recovery, it's a hard job. It's scenario-based. There's a lot of different ways that might have to proceed. It is far simpler to prevent the attack than it is to recover. However, even if I'm successful in preventing that attack, I'm going to want to look at the forensics environment and do the situational analysis so I can tell where that attack came from, and I can tell how even the first elements of it were successful. And then I can take corrective action. Even though I'm not in recovery, I still need to plug the holes, but let those people in to begin with. If something bad really does happen and we're in recovery, then the forensics capability that comes with modern integrity monitoring tools can take effect. There, I need to find out what the scope of the problem is right off the bat. I also need to find out who did it. And it's helpful to know what IP address it came from. But it's also important to know when I can go back to. So when was it last correct? I need that for my data recovery. Our objective is to make every one of these steps, which is usually quite time consuming. The recovery can stretch for a long period of time. If we're focused on automation in both the response section and the recovery section, I can save a lot of time, get us back on the air more quickly with a surgical recovery of my infrastructure environment. So in that particular case, for the software environment, since I know which modules were compromised, I can go back and create an automated restore so that those restore jobs are ready and waiting for the response team to use them, but I only have to restore the modules and the elements that were corrupted. What I don't want to do is restore your entire system and application environment, because that can cause a lot of regression for changes that you wanted to go in. Remembering that it can take a long time over here to mount this attack, weeks or maybe even months, that period of time, you know, there can be a lot of desired changes that are put on your system. If I know exactly which ones are compromised, and I restore just them, I don't run into a regression problem. However, before I do that, I probably get so excited about restore that I forget, oh, in this environment, in my forensics environment, I know who did it. So I can suspend that user ID before more damage takes place. I can take all of the elements that were compromised. I can put them in a rubber room somewhere. I can quarantine them, and then they'll be around when I have to do my post-mortem later on. That way, I can plug the holes that make it possible for them to break in the first time. But another key step is the data recovery. The modern integrity monitoring tools will help you look at the available snapsets, snap copies, image copies, the kinds of things that need to be restored. They can give you a list and guide you through that restore process for data recovery. So the conventional options are extended in these newer tools, and the recovery, both whether data or your system environment, your trusted system environment, can proceed much more quickly. So in that process, what have we done? Well, we didn't prevent anybody from breaking in, but when we did, when those bad actors broke in, we did catch them when they put in multiple back doors. We did find out where the time bombs were. We did make sure that your backups were verified and correct, as we can do that with hashing codes and integrity monitoring as well. And in that process, we make sure that not only do we understand the compromised components, we prevent the attack in the first place. However, if in some manner that attack is successful, you'll have all the tools that you need to recover it, and you won't pay the ransom. So often enough, now I take questions, and Jamie, if there was a question or two that I should answer at this point, I'd be happy to do that.
I did have someone send me a question privately, not in the main chat, and they asked that basically, have you heard of any mainframe site that has suffered from a ransomware attack or attempted?
You know, there have been rumors, and in fact, there have been unsuccessful attacks in the mainframe area, but I don't know that there's been a successful ransomware attack. However, what we often see is insiders, internal folks, making changes that expose a company to damage from someone who has gone rogue. So the same sort of tools, the same sort of protection that you would put in place to prevent an insider attack is the same sort of protection that you would have in place if someone decided to break in and try and ransom you. I believe it is only a period of time until mainframes are the real target in ransom attacks, because as we all know, they're the workhorses of IT. So I think it's important to take action both on the basis of ransomware can happen and insider attacks do happen. There are lots of stories about insider attacks and things that bypass the change process that really were malicious in nature. So I would caution you to look at those very carefully. Jamie, anything else?
No, that was the only question that I've got. If anybody else has got any questions, please do put them in the chat. You can actually unmute your line as well if you want to ask Al a question live.
Perfect.
Yep.
Okay, I'll carry on a little bit and talk a little bit more about integrity monitoring as to actually how it actually works. And then we really will open things up to as many questions as you have. So integrity monitoring is a time-to-time scanning process. So you scan your environment as often as you think it needs to be scanned. If it's your online banking system, maybe several times per day. If it's your year-end processing, maybe the month before year-end, but typically people would scan every day or multiple times per day. I have heard of customers for integrity monitoring tools that would scan dozens of times per day or more. And for very efficient ones, that's very practical. It only takes a few seconds of CPU time, even for a fairly comprehensive scan. But what the scan does is, of course, we're going to create a new set of checksums, and we're going to compare that to the baseline that we stored in the vault. So in the very first case, we create that baseline information. We say we successfully created the baseline information. We update something in some type of a vault somewhere where all of those whitelist entries are and encrypted so that they can't be modified. Then the next day we run another scan and we run another scan, and in every case we compare to what's in the vault, and in a typical case we find no changes. So there's nothing to do because everything matches exactly as it should. However, one unhappy day we find out that something has changed, and because we've been updating that baseline all the way through with the desired changes going through your deploy process, we can identify that that's a bad change because we have a current whitelist. Mainframes have never had a current whitelist before because there haven't been integrity monitoring tools capable of actually keeping those up to date. But on that unhappy day, we find a module that shouldn't have changed. We found a parameter set that shouldn't have changed. We find all of the static elements that we are monitoring that are the place that an attack takes place from. So if you think about attacking your data, where does that attack come from? It comes from the software layer. I have to alter a program to make it attack your data. So that's the kind of thing that integrity monitoring is looking for. And we're going to raise an alert because often enough, if I just deliver that alert to an SIEM or a central network operations center, there aren't the kind of mainframe skills necessary in that environment in order to solve the problem. So in addition to updating an SIEM or single pane of glass security tool, which I probably need to do from a corporate standpoint, I'm also going to have the option to send an email to my mainframe response team. Or that could even be a text message if people are on the move. In that email, any modern tool would put a link. At that link, once you click on it, would take you to a modern environment. So a GUI environment in which we can do research and find out what is the real problem. In the context of integrity monitoring, you will already know the second that GUI comes up, you will already know what's affected. And you will already know the attack interval, because every time we wrote one of these success records over here, we knew that things were still correct. So the time difference between when the last success record was written and now, when we know there's a problem, that's the interval in which the changes took place that caused them to get access to your system. That's the attack interval. Once I know what was affected and the attack interval, it's simple enough to go out to the SMF files, bring all of the up-to-date information in. Then I know what all the accesses were, and very importantly, what the updates were. So I know who did it and the exact time it was done at. And it may be more than one instance. So I'll need to have a very rich environment to display them all. But don't you think that's a lot easier than trying to take, even if you know what was compromised in some manner, to go out and look at millions of SMF records and try and find the update for that? Obviously, having a system do that for you is a lot more efficient and a lot quicker. Then, wouldn't it be nice if I could reach out to ServiceNow or BMC Helix in the cloud and actually find out, was this change approved? Was there a change request at the time all of this stuff came through? Because again, you know the interval and you know what was affected. You can do that dynamically with newer tools. In fact, in this whole process, you might want your integrity monitoring tool to raise an alert record in the likes of ServiceNow or Helix, not checking the change request only, but using that as the groundwork for whether the system should automatically log an incident record. And then, of course, the last thing a modern tool would do is if the changes were in a parameter set or in source somewhere, you could have the opportunity to do a side-by-side compare and see what the real changes were and identify if those changes look like a legitimate comment change or whether there's something much more malicious. So that's really where we focus on the respond phase of things. In integrity monitoring, we actually have to go further than that, beyond the faster analysis and forensics. We need to go into the automated recovery process. In this environment, we not only have to understand what the conventional backups are, we actually need to understand where we're going to get the data back. Because simply, in any attack, we need to recover both the data and and your trusted environment. So a key element in that, if you have immutable backups or you have only conventional backups, have the integrity monitoring tool tell you which of those backups is actually trusted and which ones we need to get which components for. So in the case of your software infrastructure that was tampered with weeks or certainly days ago, you probably want to go to conventional backups. Whereas when you're recovering your data, you probably want to go to the immutable backup, get the absolutely most recent and up-to-date copy, and then initiate your forward recovery from that data point moving forward after we've gotten required data back from your immutable or snap backups. Let's look at this in the context of what a restore actually, what the process looks like. So we went through this process. Malware got in. Integrity monitoring detected it, sent you an email to your response team. For the response team, all I have to do is click on that email, go through the forensics, and make this one decision. Was this a legitimate change? In which case, I need to learn that change and accept it. Or was this something more malicious? And I need to do that surgical recovery to bring it back to the state that it needs to be in. I may be able to prevent the entire attack and just do the surgical recovery on your infrastructure and not have to recover data at all, because I've identified this at an earlier stage. So that is much simpler for even the most experienced and existing staff, let alone new staff that will be coming in to take on these jobs. Baked into current products is also your response protocols. Every client can update information in a database so that all of the restore steps are known and pre-scripted ahead of time. That way, everybody can follow the process back and get you back on the air quickly. What does a GUI look like? In this particular case, I brought in our own. So this is really the only example of what you might see in your environment. And very clearly, you can see, I know all of the things that got changed in this environment. As soon as I open it up, all I have to do is decide whether I'm pushing this button that says run the recovery assist function, or push this button that says accept the change. Now, even the change acceptance would be in the hands of someone different than would be making the change. So it gives you separation of control and much more information and much more control over the situation. Another thing you might want to do is you might want to click on this button and see what all the safeguarded copies are, or all the snap sets or snapshots. Where are they? And how would the response protocol best guide me through how to restore my data? All of that is available by just simply one click on this interface. So in a final analysis, where are we? What have we done? This is a discussion about ransomware. And to that extent, we've figured out that what we need to do is prevent, more so even than recover. So focusing on continuous monitoring, focusing on integrity monitoring are critical in prevention of a successful attack, whether it starts inside, whether it comes from outside, whether it's malware, whether it's ransomware. It doesn't really matter. I have to have the tools in place to be able to determine that kind of problem before it affects me. Because if I get into recovery, because it is so scenario based, and you're so far down the road and you've already had a big outage, you are already in a world of hurt by the time you start recovery, let alone by the time you finish it. And if you haven't looked after the system environment, then the attacker would simply use all of the other tools that he put in place and reattack you and recompromise the database that you just restored. So in addition to that, we need to support a new generation. They're used to working with texts 724, with browser environments and GUIs, not 3270. And they will need guidance as to how to respond in every environment. Implemented correctly, this should be far less work than you are doing today. Integrity monitoring is one of the only tools that can actually deliver both better security and work-saving capabilities. If you want to have a discussion more about that area, there's a GSE session that I did a couple of years ago where we focused specifically on saving effort, but there are newer techniques available now. So anytime Jamie would, I'm sure, love to put you in contact with me, and I could certainly go in more detail through any of those points if you want it. But that pretty much wraps up my my presentation for this morning. So maybe I'll turn things over to Jamie again, and we can just see if there are more questions that have come in.
Thank you, Al. Yeah, there was one question that came in from Andy. I think he posted the message directly to me. So his question is, and I think this is in relation to the ServiceNow integration. He says, are you looking at change records for privilege requests or all requests?
That can be set up however the customer wants. So any tool that you're going to put in that's going to look at ServiceNow, there are really two issues. One, how do you match the actual component to its proper change request? And that can be done very simply on a time-based event, or it can be done if we have certain signatures and mapping between the integrity monitoring tool and ServiceNow. So while you're doing that, and part of the implementation process, typically when you activate ServiceNow Gateway, would be to make sure that you are looking for the kinds of changes that you are most concerned about. So typically that's a client responsibility. And in our particular case, we would always help the client map that out in the way that they feel that they would want to respond. So the answer to the question is, you can look for updates that are suspicious, or you can look for all of the updates in the system, and that's your choice.
Okay, thank you.
Question. Would you look at controlling privilege requests as well, so that they have to go through a change request in order for them to be actioned, so that by and large all requests have to effectively be made through the system?
No, I actually, if you think about, I think if you think about your standard deployment process that most people would have in their site today, there's probably a window at which point those deploys take place. It's a very simple job to separate these two functions and go, if you want to verify all that through your change management process, you can, but that would be more work. So what we typically see is that customers would implement a step just after their deployment and say, I just deployed a new system. Integrity monitoring, go out and learn all the changes associated with that. And it is simply a job step that says, scan the differences before the window opened and after the window opened, take those, all of those changes as being correct, update the baseline with those changes, put the hash codes in. I now have my new up-to-date whitelist, and I have only added one job step that would take a few seconds to run in order to do that. So there would be no manual updates. There would be no one-by-one change records that would need to be updated in integrity monitoring. Integrity monitoring would take the lead and find that out for you. Did that answer the question?
Yes and no, but it's answered it enough for me that I have an answer, if that makes sense.
And it should be, the important part of this is it can be set up so that it is zero manual work.
Yes, that was what I was hearing. Thank you.
Okay.
We have a couple of questions from Steve Hosey in the chat. I don't know if you can see those, or I can read them out to you if you like.
Open up the chat, see where they are. Oh, okay. Let me just start with number one, as interesting as that is. Okay, typically an integrity monitoring tool would be a client server application. So the question is, how would the solution work in a sysplex from a reporting and recovery method? So typically what we would see is every LPAR would have an agent, and that could be sysplex wide, and they would report to the server component. So the server component typically would hold the whitelist for multiple LPARs for potentially multiple systems. It is possible that in some cases, you in a very large sysplex, or one that contained actually multiple sysplexes, or where you had a disaster recovery site that was running at some distance, you might want more than one integrity monitoring server, and you might put those one per sysplex, or you might put two in, one to monitor all sysplexes in a production environment, and one to be instantly available in your disaster recovery site, so that the only thing that would be necessary is that up-to-date whitelist, and you would run your recovery from that location. Next question is, does the browser, I hope that answered the question. Does the browser interface provide reporting roll-up? An organization has 50 mainframe systems in the complex. Some are sysplex, some are standalone. Where's the enterprise view? Again, I would say that in that environment, it would be very easy to run one central server, and we've seen this with our product. I haven't seen it with others. We've seen it with our product where we would run up to 50. Well, 50 is an interesting number here because we've seen customers with 44. Because our product is fairly new, we haven't rolled out to all 44 yet, but you know, we're certainly well into the rollout. In that particular case, they had one central server that reported on all of those environments. So all of the information, the relevant information, would be painted for any exceptions found, and we're thinking we're not going to find them on 50 systems at the same time. We'll find them like everything else on one or two that are going to be compromised first. And if you're scanning frequently enough, we'd find them at that stage and do a surgical restore. But the enterprise view would always come from the server. So in truth, all of the alerts that we raise can also be uploaded to your SIEM. So if you wanted to manage from your SIEM environment, you could do that as well, because it would be up to date with all of the messages that would come up within the browser environment or within the integrity monitoring or store capability. Who could see your messages? You define who can see our messages. You know, some of them would be written to console. The alerts will be delivered for a particular group of data sets to a particular response team. So if we were scanning the CICS environment, in some environments, and we found a problem and we raised an alert, in some environments, you might want to direct that towards your ZOS team because you don't have a dedicated CICS team. In other environments, you might want that to go to the CICS team and actually only the CICS team, or you might want a duplicated copy to go to the ZOS response team so that they're aware that there's a CICS problem ongoing. So again, those options are typically something that are mapped out at implementation time, but I think there's a variety of alternatives that, in my experience, you know, of 4 or 5 years in this field, all of those get laid out at implementation time. So we think there's a solid solution to these kinds of problems, and there's no need to wait for ransomware or some other successful kind of attack to take a mainframe down. The time to act is before you have a problem. So anyway, with no more sermon, I see there aren't any more questions. So unless somebody has one for me on the fly right now, I shall thank Jamie very much for his assistance today. And I thank GSE for the opportunity to talk about new technology.
Thank you very much, Al. Thanks once again for coming to GSE to talk to us about this thorny topic. What I will say to everybody on the call, of course, having a ransomware attack on any enterprise system is huge headache, not only to customers, but also to the people that are supporting that system. But think about from a personal perspective, all I would say to you is, at home, from ransomware attack perspective, taking that sort of proactive protection, do a monthly backup at least of all of your data, your photos, whatever it happens to be, and keep it offline. Don't connect it to any computers, but make a point of doing it and doing it regularly, so that if you do suffer a ransomware attack in your personal life, that you do have something that you can recover from. I'm just telling you this from I heard of a friend recently who suffered from it, and they had no backup. So just make sure but the key thing is you need to keep it offline so that doesn't get infected as well. So yeah, thanks once again, Al, and apologies, Al, I forgot to, it was an early start for you. You're from Calgary, aren't you, in Canada? Is that correct?
That is true.
So thanks for.
So more importantly, Jamie, it was an early start for my computer, and he didn't wake up very well this morning.
No. Maybe you've got ransomware, eh?
Yeah. Oh, surely not. I scan regularly.
Good. So yeah, I've put the feedback link in the chat, folks. So if you could, as with all sessions, provide your feedback. This goes, of course, feedback for the presenter, and also for us at GSE, but for those of you who are collecting CPE points, for your certificates and things in education portfolio, that counts towards that and will appear on your certificate, which you can download, by the way, from my GSE. So that was session 7D, link in the chat. We do have a break now, so we've got a 25-minute break, and then up next in the security stream at 3:30 UK time, we've got Mark Nelson from IBM RACF development team joining us to give us a RACF update. So we really hope you can join us for that. Don't forget that we hope you do join us back in the security stream, but there are other sessions, of course, running in other streams as well. So thanks once again, everybody, and we'll see you in the next session. Thank you.
Thanks, Jamie.
Thanks, Al. Bye.